In this video, I'm going to demonstrate how to use Gauss-Jordan elimination to solve a system of two equations in two variables. So we start with the system 2x plus 3y equals -6 and x minus 2y equals 11. The first step is to create what is called an augmented matrix. To create the augmented matrix, we simply use the numbers from the system. That would be the coefficients of x, the coefficients of y, and the constants. So the coefficients of x are 2 and 1. The coefficients of y are 3, -2, and the constants are -6 and 11. We then put those in brackets, and we have an augmented matrix. Now, if we leave off the constants in the third column, and we just have the 2, 1, 3, and -2, we would have what is called a coefficient matrix. But when we're using Gauss-Jordan elimination to solve a system of equations, we create an augmented matrix. The next thing that we want to do is to use the row operations to reduce this to what is called reduced row echelon form. Reduced row echelon form. And there are three row operations. The first row operation is to interchange two rows. And that, of course, is explained in my notes. The second row operation is to multiply any row by a non-zero number. And the third row operation is to add a multiple of one row to another row. So to get this started, what I'm going to do is I'm actually going to use the first row operation. I'm going to interchange two rows. I'm going to take row 1 and I'm going to interchange it, that's what the little double arrow means, with row 2. And so my new matrix will look like this. 1, -2, 11, 2, 3, -6. Now the reason that I want to do that is because we want this number in the first row, first column, to be a 1. That is always the first step. The number in the first row, first column must be a 1. Then what we want to do is every other number in that row needs to be a 0, which means we need to turn 2 into a 0. And the way to do that is to use another row operation. Take -2 times row 1, add it to row 2, and then replace row 2. That's adding a multiple of one row, row 1, to another row, row 2. So what do we get when we do that? So the first row is not changing. So I always like to write down the things that are not changing. I'm not doing anything to row 1. It stays the same. Row 2, however, I'm going to take -2 times this 1, and then I get a -2. Added to 2 is 0. Then -2 times -2 is 4, plus 3 is 7. -2 times 11 is a -22, plus a -6 is a -28. And I have completed my row operation, and I have a new matrix. So my objective is complete. I have a 1 in row 1, column 1, and I've changed the 2 into a 0. Now we move to the second column. And in the second column, we want to change this number now into a 1. Well, the easiest way to do that would simply be to multiply it by its reciprocal. 1/7 row 1 will replace row 2 will replace row 2. And so what we have now is, again, the first row is not changing, but the second row is going to look like this. 1/7 times a negative 28 is a negative 4. So my objective to turn the 7 into a 1 is complete, but now I need to turn this number into a 0. And to do that, I'm going to take 2 times row 2, add it to row 1, and replace row 1. So in this case, row 2 is not changing, but row 1 will change. So 2 times 0 added to 1 is just 1. 2 times 1 is 2, plus the negative 2 is 0. 2 times negative 4 is a negative 8, plus 11 is 3. So how do you know when you are done? You know when you are done when this part of your matrix is the identity matrix. When you have the main diagonal with 1s and then 0s in every other spot. So you have 1, 0, 0, 1. This is called reduced row echelon form. And when you have it in reduced row echelon form, it gives you the answers. Make this a little bit neater. So from the matrix 1, 0, 3, 0, 1, negative 4, we know that this was the x column, this was the y column. So what we really have here is 1x plus 0y equals 3, which simplifies to simply x equals 3. And then here we have 0x plus 1y equals negative 4, and that simplifies to y equals 4. And those are our answers. Negative 4. Now you can check those by going back to the original problem and substituting those values in there. So we have 2 times 3 plus 3 times negative 4 should be equal to negative 6, and indeed it is. And 3 minus 2 times a negative 4 is 11, and both of those are true statements, so it does check out. The solution to this problem is x equals 3 and y equals negative 4. So there's a lot of terminology in the work that we're doing with matrices, but it's important that you understand the terminology. Row operations, matrix, augmented matrix, identity matrix. So again, make sure that you're reading over my notes and make sure that you're doing the example problems. Watch the other videos that I've posted and let me know if this has been helpful. Bye-bye.